Hello, good day to you. Today we are going to be talking about fractions and decimals and how those two are related. Now we've already covered this somewhat in previous sections, but today we're just going to focus on comparing these fractions and just seeing how they do connect with each other. Okay. So to start out, we're going to actually just convert some decimals to fractions. Then ultimately we're going to end up reducing them, writing it in simplest form. You may remember that to convert a number like this to a fraction, remember this is tenths, hundredths, thousandths. In other words, we've got to have 1,000 on bottom, and so we'll take this 1,000, put it down there, we'll put 275 up top, and that's how we get that. The other thing that you could think about is if we have 3 decimal places here, then we'll have a 1 with 3 zeros on the bottom. Then after this, we looked for a GCF between the top and the bottom, and then reduce those to get our fraction written in simplest form. So for this first one that we're going to do together here, I've got 0.33. Now this is read as 33 hundredths. And the answer to that ultimately ends up just being 33 over 100. I know this for a couple ways. One, by its name, 33 hundredths. Or I could say, look at this, it's got 2 decimal places. And so I could just put a 1 with 2 zeros down there. And so I know it's going to be over 100, and then I'll just put that number there. 33 and 100 have nothing in common, so they are done. We can't reduce that anymore. All right, let's take a look at the next one here of 0.65. So again, there's 2 decimal places here, and so that means that right away I know it's going to have 2 zeros, or in other words, 100 on bottom, and it will be 65 on top. Now remember, this is read as 65 hundredths, and so I could just think of it that way too. The next thing I'll do is look and see what goes into both of these. I know that they end in a 5 and a 0. That means that I could actually factor a 5 out of the top and the bottom. So if you'll think of dividing the top and the bottom by 5, then on the bottom that gets us 20, and on the top that gets us 13. 13 and 20 are said to be relatively prime, meaning they have no common factors. So we're finished. 13 20ths. Next we have 40.48, so just like the others, that's 48 over 100. Then our GCF, I don't know exactly what GCF, but you know what, I know that 4 goes into these, so let's just start with that. You know, maybe you didn't see 4. Maybe you looked and I said, man, I didn't think of 4, I thought of 2. They're even. So I thought of 2. Okay, well, if you think of doing a 2, that's okay. You can divide a 2 on the top and the bottom. That'll take you down to 24 50ths, and then hopefully you look at that and say, oh, they're still both even, and that means that we can take another 2 out of the top and the bottom, right? Divided by 2, divided by 2. That will take us down to 12 25ths. So you can do it that way too. If you go straight to 4, you'd get to here quicker. If you didn't think of 4 and you said 2 and then 2, you still get there. Okay, now they're going to get a little bit harder because some of these numbers get to be a little bit bigger. This is 485 over 1,000. I know that because there's 3 decimals here now. I see that they end in a 5 and a 0, so that makes me think about dividing a 5 out of the top and the bottom. So if I divide a 5 on the top and the bottom, that one's pretty easy. That's just a 200. Now I actually have to do a little work here. 5 goes into 485 97 times. There we go. 97, I believe that's a prime number and definitely doesn't fit into 200, so we are done. 97 200ths. Okay, down here I've got 0.052, or in other words 52 1,000ths. I do know that 4 goes into these, so 4 will go into this 13 times, and 4 goes into 1,250 times, and then we're done. 13 250ths. I do want to point out that I always write my fractions vertically like this. It's not wrong to write them like this. It's just that as you work through a lot of higher level maths, writing fractions like this can be problematic. For instance, if you have something on bottom like a binomial, You know, if you want to write it like this, if you're talking about 2 over x minus 2, and you write it like this, I don't know if you mean this x minus 2 to be in the denominator, or if you just mean 2 over x and the whole thing is minus 2. It's very ambiguous. And so that's why I always write my fractions vertically and not slashed to the side. And like I said, you'll find a lot of other mathematicians doing that as you advance through higher level maths. So, here we've got 0.325, or in other words, 325 1,000ths. I know that 25 actually fits into these. So 25 goes into this 13 times, and 25 goes into 1,000. Well, 25 goes into 104 times, and then it's a factor of 10 larger. So 13/40ths. If you didn't think of it that way, then why don't you just try dividing 5 and then dividing by 5 again. Right? Convert the following into a mixed number. What we've got here is, you can think of this as 7 and 45 100ths. This is one way of doing it, right? And just put the big 7 out front and then 45 100ths. Next, I would probably go through and divide these by 5. So that would be 9/20ths. So what we get is 7 and 9/20ths. So that's one nice way of doing this. You could have started this out with 745 100ths, reduced it all down, and then you still end up with the same thing. I think I like the way I did it first, though. Here, the last one on this page, we've got 3.75, or in other words, 3 and 75 100ths. And hopefully you guys spot this 75 and the 100. You're like, hey, I know 25 goes into those. 25 and 25. Right? Maybe not, but hopefully you do, because I always think of quarters. That makes 3/4. So what I have here is 3 and 3/4. Okay, we're going to go the other way now. We're going to convert some fractions into decimals. And so we're going to look at a couple different ways of doing this, but the first way to do this, and this is the way that I do this quite a bit, and I just don't even really think about it all that much, is that if you can make the denominator some multiple of 10, then we can very easily convert that into a decimal. So for instance, if I have 3/20ths, what would I be thinking about is, how can I make this into some power of 10? Well, I know I can turn that into 100 by multiplying the top and the bottom by 5. So I said I can turn 20 into 100 if I go times 5. So whatever I do to the bottom, I also got to do to the top. That gets us 15/100ths, or 0.15. So keep that in mind. What we're going to be doing is trying to change the bottoms into factors of 10, powers of 10. So I have 4/5. I know I can turn this bottom into tenths. And I would do that by multiplying this bottom one times 2. That's how I can turn this into 10. And so therefore I've got to take the top one times 2, and that will turn this top one into 8. So I end up with 8/10. Oh, I actually turned it into a decimal now. So I almost forgot. That means that my answer to this would be 8/10, or just one decimal place, right? And so we'd probably write that as 0.8. So for this next one, a 4, I got to think about what kind of powers of 10 does 4 fit into. Well, 4 doesn't go into 10, but 4 does go into 100, and I would get there by multiplying 4 times 25. 4 times 25 is 100, so therefore let's do the top one times 25 as well and get to 75. 75 100ths. So 0.75. Or you could just think of it, the fact that the bottom is 100, we'll have 2 decimal places. Okay, next I have 3/25ths. So 3/25ths, we're going to do the same procedure. Let's think about, I know 25 actually goes into 100 rather nicely. If I just multiply this times 4. 25 times 4 is 100, so let's take the top times 4 as well and get to 12. So that's how I get 0.12, or 12 hundredths. All right. Why don't you go ahead and try to do the rest of these and then come back. So just do a quick pause on this and then come back. Okay. All right. So 11/20ths, I can turn that into hundredths, and we'll do that by multiplying by 5 on bottom and 5 on top. So that's going to turn into 55 hundredths, or 0.55. Okay. And then down here, 50ths. 50ths, this goes, this will turn into hundredths very easily, because all I got to do is multiply it by 2. Times 2 times 2. That's going to make 34 100ths, or 0.34. All right, and the last one here, you got to think about 250. Well, 250 will actually go into 1,000 quite well. So we're going to do that by multiplying times 4 and times 4. So if we do that, that will turn this top one into 4 to 6, 624 thousandths. Or for our final answer will be 0.624. Okay? And then the last one here, last example to think about, we got to say, can we do that same thing with 5/8? Well, I happen to know what you would take times 8 to get into a power of 10, but a lot of people might not. So what you could think about is being like, well, does 8 go into 100? And you might test this out. You know, what do I take times 8 to get to 100? It's not nice. Okay, you know, so 8 goes in here one time, and we get 20, and so I get this remainder, right? 12.5 is what it comes out to be. So it's not 100, right? And then what we might say is, well, what about 1,000? Does 8 fit into 1,000? Okay. Okay, 8 does go into 1,000 pretty nicely, right? We get that. Bring the last one down. And then it's 125. So if I take 8 times 125, that will make 1,000. So I could do it like this and do 8 times 125 equals 1,000, and we'll take 5 times 125 to be, let's see, that's going to be 625 thousandths, which makes 0.625. Okay, so yes, the same process does work. It's just not very nice. It's just not that, it's not a great way of doing this. So instead, we tend to use other methods. Okay, we tend to use things like long division in order to change those decimals. So if we want to convert 5/8, what we can do is we just take 5 and divide it by 8, and then we just keep going until it goes in evenly. Okay, so we'll keep going, and you just kind of keep adding zeros on until it works out fine. Now, this is what we call terminating decimal, meaning that it ends. It goes into it evenly. Eventually, we have a 0 down here. Okay, but not all numbers work that way. We also have something like this where we get a repeating decimal. And so I want you to look real closely at this, because sometimes repeating decimals are hard to spot. You're just kind of wondering, like, man, will this ever end? So if you take 7 and divide it by 11, 11 goes into 76 times. You can see we take the 6 times 11 and get 66. We subtract and we get 40. Then we would say 3, subtract and we get 70. Then we would get 6, and we keep going. And notice that what's going to happen is this is going to keep going. We're back at 70, and you'd say 6 again. And then we'd get 4, and we'd say 40. Oh, okay, well that goes in 3 times. So we get 0.63, 63, 63, 63, 63, and so on. So what can happen though is when you spot the fact that you have the same number here, down here happening, you've definitely hit a repeating decimal. Okay, so you just want to find the part that repeats, and in this case, it just goes 0.63 and then it starts over. So we would write that like this, 0.63, and we just put a little bar over the top. That's how you write this. This bar means to keep going and going and going and going. Now, there are other examples besides 7/11 that I didn't do because most of you know. But if I was to say convert 1/3 into a decimal, most of you know, oh, that's just 0.33. Well, it's actually 0.33333333333333333. Okay, and so on. And so ultimately, what we would just do is just put 0.3 with a little bar over the top. So this is a little bit better answer than just writing 0.3. Okay. All right, let's take a look at just a few more examples, and then we'll wrap it up here. So we do have some long division to do. Let's get cracking. Now, if we look at I actually want to pay really close attention here to the directions because it says convert the fraction to a decimal if non-repeating, round to the nearest thousandth. Okay, and that's really important because the nearest thousandth would be 3 decimals, but remember we actually have to go out 4 decimal places so that we can round accurately to 3 decimal places. And then if it is a repeating decimal, put the bar over the repeating part. See, all of these are going to be either repeating decimals or, well, or they'll be just be nice decimals, be terminating decimals. But the problem is that sometimes the repeating part of this goes on for a while. And that's the case here with this 5/7. Okay, 5/7 is a repeating decimal, but it goes out a ways, and it actually goes out beyond the thousandths before it starts to repeat. See, in the repeating decimal for this, it's actually 6 decimals long. Okay, it's going to be 0.714285, 714,285, 714,285. But that's actually beyond how far our our directions say to go, and so I just want to point that out. See, these are all rational numbers. That's a classification of numbers that just means they can be written as a fraction. It means that they would be terminating decimals or repeating. Okay, but let's keep going and show you how we got that. So if I take 5 and I divide it by 7, we'll do this. And we'll say 7 goes into this 0 times, so I'll put my decimal right here. And now I'm going to start adding on zeros. I'm going to get a little bit thinner pen to make things a little easier to read. Okay, 7 goes into 50 7 times. 7 times 7 is 49. 1, and I'm just going to put another decimal down here and bring it on down. 7 goes into 10 one time. We'll put another decimal on and bring it on down. 7 goes into 30 4 times. Okay, so now this is to the nearest, this is the thousandth place right now, right? And now I bring the next one down because we have to check and see about the 10,000th. If it says round to the nearest thousandth, we have to go out to 4 decimals so that we can then round to 3, okay? 7 goes into 20 just 2 times here. So what I have is 0.7142. Now because this one right here is little, it means that we're ultimately just going to chop it off. And so I get 0.714. That is rounded to the nearest thousandth. This is going to keep going for a while. Okay, like I told you, it's actually 0.714285, 714,285, 714,285. Like if you were going to write the whole thing properly, it would look like that. But that's not what our directions say, so you always got to read directions carefully. All right, the next one, 8/9. We'll take 8 and divide it by 9. Of course, 9 doesn't go into 8. And so this will be 8 times 72. I just add 1 on. Uh-oh, look at that. I'm back at 80. I'm trying to figure out how many times 9 goes into 80. So right now, I actually know this is going to be a repeating decimal. Not just because this says 88, but because I'm actually doing the same thing. This 80 is the same, right? I mean, we can keep going with this if you really need to prove it to yourself. Okay, we can keep going, but we don't need to, because we have that 80 that's just repeating over and over and over again. So this would be 0.8 bar. Okay. 2 and 10/17. Now, when I do something like this, I like to do just the decimal part of it, you know, the fraction, and then we'll add a 2 on the front. So let's take 10 and divide it by 17. 17 doesn't fit into 10. That's okay. We'll have our 2 out here anyways, okay? So this is 0, and then 17 does go into 100 6 times, 5 times. Okay, that'll be 85. And then we'll bring another one down. And now that goes into 150, 10, 9, 8. Looks like 8 times. And we'll take 8 times 7, get 56. That's 136. Oh, that's going to be the same one then too, right? Because it's going to be 0.588. Okay, and then 17 goes into 40 only 2 times. So notice that right here, with this part right here, because that's small, we're going to ultimately just end up chopping it off, right? It's like rounding down. So I haven't done anything with this 2 out front yet, so I have a big 2, and then I still have 0.588. So my final answer will be 2.588. And there we're done. We've rounded to the nearest thousandth. These are great to check on a calculator too, by the way. Like, there's nothing wrong with doing that. Just making sure you're doing things right, making sure I'm doing things right. 14 doesn't fit into 9, but it does fit into 90. Okay, so 14 goes into this, looks like we're going to 6 times. So 24. We get a 6, and then we'll just bring the next 0 on down. So 14 goes into 60, 4 times. 16. Okay. I'm going to bring the next one down. 14 goes into 40 only 2 times. So that's 28. I'll bring the next one down. Now this is the one that's going to teach us about rounding, right? So 14 is going to go into that 10, 9, 8 times. So because this went in here 8 times, I'm going to end up rounding up, right? Because of this number right here, because that number is bigger than 5, it means I'm going to round up on this too. So this will be 0.643, right? Because this one is a 5 or larger, so it means that this one's going to round up to the next number. Okay. Ooh, we got a lot going on here. Who put all these problems on here? All right. We've got 8. Let's just cast that aside for now, and let's focus on the 3 divided by 22. Okay. So if I want to do that, I'm going to say 22 doesn't fit into 3, but it does fit into 30. Okay. So we got that. This will be 8, and I bring this one down. 22 will fit into 80 3 times. So we get 1, 3, that's 66. That's a 1, 4, and here's a 0. I'll bring that one on down. 22 goes into 140, I think 6 times. Yep. And then I get 8, and I bring the next one down, and oh, I spotted it. Did you spot it? Did you see it? Look right here. 80, 80. That means it's going to repeat. So from here on out, it's just going to keep repeating. Right? 22 goes into here, 3 times and then 6 times, and then 3 times and 6 times, and 3 times and 6 times. You can check it out if you want. You can put it in a calculator if you want. But what that means is our answer is going to be 0.136, and you got to be really careful because what's repeating? Only the 3, 6, 3, 6, 3, 6, 3, 6. That means we put the bar over just the 3, 6. Be careful. Do not put it, or don't get lazy and just be like, oh yeah, well I meant it over the 3, 6. Or sometimes people aren't quite sure what to do, and so they just kind of do that, and they put it right between the two. No, 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 no. I'm not having it. Okay, make sure this is very clearly over the 3, 6 and not over the 1. This one you're kind of like, maybe, maybe not sure. So don't be ambiguous about it. All right, next we got 35 eighths. So we'll start out with 35 inside. We'll put the 8 on the, oh, you know what? I was talking about all that other. I forgot about this 8 right here. So don't forget to add that 8 on. Whew, that was close. I know some of you guys were yelling at me. I heard you. So 8 does fit into 35. It goes in here 4 times. So we'll start with that. And then we would say something like this. I'd be like, well, we have 3 left over, so all I'm going to do is put a decimal here, and I'll start adding zeros. And we'll put as many zeros as we need. We don't know how many we're going to need. Okay, so we'll just do that, and now we can start bringing them down. 8 goes into 33 times. We bring the next one down. 8 goes into 67 times. And then we bring the next one down. 8 goes into 45 times. And then we're done, right? Because that's 0. So the rest of these we wouldn't need them. This is just 4.375. 4.375. And we're done. Okay. So again, like I said a minute ago, these would be great ones to, pause, see how you're doing, make sure, pause the video, and you go ahead and do these. All right, I'm going to do them now. So 1 divided by 3, remember, leave that 6 out to the front. 3 goes into 10 3 times. I mean, this is one you should probably know. We actually kind of did it earlier. 3 times. Oh, it's going to repeat. 6.3 with a bar over just the 3. Okay. 17/18. Ooh. 17/18. This one looks like it's going to get ugly. 18 goes in here 0 times. And then I bet this is 9. So let's just multiply it out and check it out. 8 times 9 is 72. That's 162. There we go. That's 80. Because I'm bringing the next one down. Okay. Then 18 goes into 80 4 times. 32, 72. Ooh, that's kind of nice. Look at that. That wasn't quite as ugly as we thought. We have that 80, and that 80 is repeating. Because we have a repeating thing down here, it's going to keep repeating. It's just going to be 4 and 4 and 4 and 4 and so on. Right? It's just going to keep going. So our final answer to this one, then, I'm going to clear this out up here a little, comes out to be 0.94 repeating over just the 4. Okay. All right, let's wrap this up. We'll do a few last problems here and call it a day. When we want to compare fractions and decimals, there's a couple good ways that you can do this. One way is to make it so that they have the same denominators, or the other way is to make it so they have the same number of decimal places. Now for what we're doing here, I think that probably writing them with decimals would be most appropriate. So if we take 8 and divide it by 9, we can do this. So we'll take 8 divided by 9 gets us 0 point, and then this would be 8. My pen's disappearing now. Bring the next one down, so we get 0.88, and I don't even really need to keep going. If I were to write these with the same number of decimal places now, I would say 0.80, and how does that compare with 0.88? Well, 0.80 is less than 0.88. So this is how you do it with decimals. You also could change them both to fractions, get common denominators, and then compare the numerators. Either way is fine. They're both totally good. So let's think about doing this as easy as we possibly can. Here we've got 0.23 and 0.30. Well, I'm sorry, this is just 0.3. What I want to do is make this into 0.30. Now they're both written as hundredths, and of course 23 hundredths, and when I compare that to 30 hundredths, 23 is less than 30. Okay, so this would be writing them as fractions. This is just writing them with the same number of decimals. Okay, so let's go on to this one. 3/4, most people actually know that one as a decimal. So I would say the easiest way to do this would be to say this one is 0.70, because you can always add zeros on the end. And let's compare that with 0.75, right? 0.70 is less than 0.75. So that's the way that you would do it with decimals. If you were going to do it with fractions, you would say 7/10 and 3/4. You want to say, well, what would the common denominator between tenths and fourths be? And it would actually be 20ths. So if I take this times 2, that'll get me 14. And if I take this one times 5, that'll get me 15. So 15 is larger than 14, and so I would use, once again, that same sign. 14/20 is less than 15/20. I think the decimal's easier in that case. All right, okay. 5/6 compared to this. So I'm going to go ahead and change this to a decimal. Now, the more you do these, you'll actually start to memorize some of these if you do enough of them. Like, I know what this is as a decimal, but I'm going to do it out long division style because I think most of you probably don't have it memorized. So 6 goes into 5 0 times, but it does go into 50 8 times. And then we'll just put another 0 on here and bring it on down. Well, sorry. Jumping ahead of myself. I already put a 0 on and brought it down. Okay, 6 goes into 23 times. And then we bring the next one down. And then that would be 3 times. And look, we have this 20 that's repeating. So that means this one is actually 0.833. It's going to be 0.83 repeating. Right? And if I make these have the same decimal places, I get 0.833 and 0.830. Therefore, I would use a greater than symbol for this, right? Because this left one, which is 0.833, is greater than 0.830. Okay. The next one, we've got 7/8, and I've got 9/10. Let's do this one at fraction style. We haven't done too many of those. 9/10. I got to think about common denominators between 8 and 10, and it's actually 40. So if I could turn both of these into 40ths, then I'll be able to compare just the numerators. Right? And so I'd say 8 times 5 is 40, so I've got to do the 5 on the top and the bottom. That's 35/40ths. And down here I'll take 10 times 4 to make 40. So this becomes 36 when I do that top and bottom. So what I have here is 35/40ths and 36/40ths. And of course the 36 is much larger. So it would look something like this. right? 36 is larger than 35, so I would use this. Of course, you could change those to decimals too, but yeah, we already did that. Oh, stop jumping. Okay. All right. Next, let's do. What should we do? Let's go fractions again. We haven't done too many of those. This one is 13/100ths, and over here this is 5/40ths. And if we want to get common denominators, I know I could, I could go to 200. That would work. I could even go to 400. Nothing wrong with that. They don't have to have the least common denominator. They just have to have a common denominator. So I could multiply this one times 10. And what that gets me then is this will give me 50/400ths. And if I come over here to the other side, I can take this one times 4, right? And what that will get me is 52/400ths. Because they're both 400ths, we just compare the numerators, and we would see that the left side is much bigger, hence a greater than sign. Okay, so I like that there. Next, we'll go ahead and change this one into a fraction. Now, there's part of this is just having some experience, trying to find a common denominator between 100 and 9 is not great. I mean, it would be 900, right? But sometimes when those denominators get to be really big, it's just not worth it. So let's just take 5 and divide it by 9. We'll just change this into a decimal. 9 goes into 50 5 times. That's 45. Oh, look, it's repeating already. I already know it. It's going to be, because 9 goes into 55 times, all right, and 45. I just know some of you are like, wait, what? How do you see that so fast? I'll prove it to you. Okay, we have this repeated 50, 50, 50. So what this is then is this is 0.55, and I'm comparing that with 0.555555555. So I probably better use at least 3 decimals. There. Now I can clearly see which one is in fact larger. And the one on the right is much larger. It looks something like this. So this is actually read as a less than sign. 0.55 is less than 5/9. So it's just a few more things we did with decimals today. Going back and forth between fractions and decimals, the connections between the two. I like working with fractions a lot, but decimals definitely have their place. So I hope this was helpful to you. Good luck with your decimals.